Hi and welcome to Section 1, the realm of supervised learning. Now we move on to the first video of this section that deals with pre-processing data using different techniques. In this video we're going to take a look at different techniques for pre-processing data. We'll go through mean removal and take a look at scaling, and then we'll move on to data normalization, binarization and one-hot encoding. We'll use various Python packages such as numpy, scipy, scikit-learn and matplotlib during the course of this course to build various things. If you use Windows, it is recommended that you use a scipy-stack compatible version of Python. You can check the list of compatible versions at www.scipy.org/install.html. These distributions come with all the necessary packages already installed. If you use Mac OS X or Ubuntu, installing these packages is fairly straightforward. Here are some useful links for installing and configuration. numpy, docs.scipy.org/doc/numpy-1.10.1/user/install.html. scipy, www.scipy.org/install.html. scikit-learn, scikit-learn.org/stable/install.html. matplotlib, matplotlib.org/1.4.2/users/installing.html. Make sure that you have these packages installed on your machine before you proceed. In the real world, we usually have to deal with a lot of raw data. This raw data is not readily ingestible by machine learning algorithms. To prepare the data for machine learning, we have to pre-process it before we feed it into various algorithms. Let's see how to pre-process data in Python. To start off, open a file with a .py extension, for example preprocessing.py in your favourite text editor. Add these lines to the file. We just imported a couple of necessary packages. Let's create some sample data. For that, we'll need to add this line to the file. We're now ready to operate on this data. Data can be pre-processed in many ways. We'll discuss a few of the most commonly used pre-processing techniques. So the first technique is mean removal. It's usually beneficial to remove the mean from each feature so that it is centered on 0. This helps us in removing any bias from the features. Add these lines for that. We're now ready to run the code. To do this, run this command on your terminal, python preprocessing.py. You'll see an output like so on your terminal. You'll see that the mean is almost 0. The standard deviation is 1. Awesome. Let's move on to the next technique, scaling. The values of each feature in a data point can vary between random values, so sometimes it's important to scale them so that this becomes a level playing field. Add these lines to the file where our specified range is 0 to 1. Now let's run the code using the same command as before. After scaling, all the features' value range between the specified values. Nice. The third technique is data normalization. Data normalization is used when you want to adjust the values in the feature vector so that they can be measured on a common scale. One of the most common forms of normalization that is used in machine learning adjusts the value of a feature vector so that they sum up to 1. Add these lines to the previous file we've opened, that is preprocessing.py. This is the data normalization code. Now if you run the Python file, you'll get this output. Awesome. This is used a lot to make sure that data points don't get boosted artificially due to the fundamental nature of their features. Now the next technique is binarization. Binarization is used when you want to convert your numerical feature vector into a Boolean vector. Add these lines to the same Python file, that is preprocessing.py. This is the print command for binarized data. So let's run the code. Oops, there's an error, syntax error. Let's go back and see what went wrong. Oh, I haven't ended the comment. Let's do that now. Let's see if it works now. Yes, so this is the binarized data output. This is a very useful technique that's usually used when we have some prior knowledge of the data. Now, the next technique is one-hot encoding. A lot of times we deal with numerical values that are sparse and scattered all over the place. We don't really need to store these big values. This is where one-hot encoding comes into picture. We can think of one-hot encoding as a tool to tighten the feature vector. It looks at each feature and identifies the total number of distinct values. It uses a one of k scheme to encode the values. Each feature in the feature vector is encoded based on this. This helps us to be more efficient in terms of space. For example, let's say we are dealing with 4-dimensional feature vectors. To encode the nth feature in a feature vector, the encoder will go through the nth feature in each feature vector and count the number of distinct values. If the number of distinct values is k, it will transform the feature into a k-dimensional vector where only one value is 1 and all other values are 0. Let's go to the editor. We'll uncomment these. So this is the line of code you need to add. Now let's run the code. This is the output. In this example, let's consider the third feature in each feature vector. The values are 1, 5, 2 and 4. There are 4 distinct values here, which means the one-hot encoded vectors will be of length 4. If you want to encode the value 5, it will be vector 0, 1, 0, 0, and only one value can be 1 in this vector. The second element is 1, which indicates that the value is 5. That's all about one-hot encoding. Well, that ends this video about pre-processing data with different techniques. Cool. In the next video, we'll take a look at how to do label encoding.